Okay, welcome you guys to my new lecture about equations, and in this topic I will come back to linear equations and try to show you how to actually solve linear equations, okay? And not only linear equations but a system of linear equations. And just have a look at this. We have a system with two variables. This means, so maybe you remember the standard form for a linear equation was ax plus b equals c, but we only had one variable, which was actually the x, and now we have also another variable, and we call this variable y. Now this is one of the general forms how you can write it. It's these parts here, a11, a12, and a21 and a22 are called coefficients, and they have these indices. It's not important actually for you right now to actually understand this, but I will tell you the first index means which equation this is, and actually this is the first equation. Actually this is also in the first equation, so we have to have a 1 here, and these are in the second equation, and the second indice tells you which variable this is. It's the first variable, and this, if you call the first variable x, this is x, and this is the coefficient of the second variable in the first equation. And analogous to that, you can use this as being the coefficient of the second variable in the second line. And these b's are numbered. b1 is the right hand side of the first equation. This is the right hand side of the second equation. Now, how does this look with three variables? Actually pretty similar. Now we have 1, 1, 1, 1, 2, 1, 3, because we have three variables. And for example, aij means the jth variable. For example, if we had 2, 3, this would mean the third variable, which is actually z, and 2 would mean in the second equation. Okay. Sometimes people also refer this as row and column. Okay, I as row and this as column. Not very important. Actually, you can just write this down. Okay, we will actually solve one of these types with a very fast and elegant method. So these are pretty easy to solve actually. But we will start off with the easier case with two variables, and then go forward and try to solve this with three variables. Okay. Now let's have a look at our example. We have 3x plus 4y equals 2. In the second equation, it's good to bring in some names. This is the I don't know how to call this in English, Romanian numbers. It's not Romanian, but Romanian. Forget about it, okay? So this means 1 and this means 2. And the second equation is 1 times x plus 2 times y equals 1. So our b1 is 2, our b2 is 1, our so the 3 is actually a11 because it's the coefficient of the first variable in the first equation, and this is a12 because it's the second variable in the first equation, and this is a21 because it's the first variable in the second equation, and this is a22, the second variable in the second equation. Okay. Now what do we do? The steps are pretty easy. First of all, we look at this. So this is a very simple and not hard way actually to solve if you have only two variables. You look at these points. I will refer them as the leading coefficients of your linear systems, because your 3x plus 4y equals 2, and here we have 1 multiplied with x plus 2y equals 1. Now I already wrote this down. Here in the first equation I will multiply with 1, which is actually this. In the second equation I will actually multiply with 3. What am I aiming to do with that? The idea of doing this is that we get in front, so here we have different leading coefficients. By doing so, we will get the same leading coefficients. So we get 3 times 1, and here 1 times 3, which is actually the same. Now just have a look what happens. So we have 3x plus 4y plus 2, because we only multiplied with 1. It didn't really change anything. The second equation, in contrast to that, we multiplied 1 with 3, we got this 3 here. We multiplied 2 with 3, we got this 6y here. And we multiplied the 1 with this 3. Okay, maybe you're wondering why I actually did this. Just have a look at this. It now looks pretty good somehow, because we have 3x here in the first equation, and we actually have it also in the second equation. So one could just subtract them, and you would eliminate the 3x. Okay, now look what subtract means. Okay, we do a subtraction. We do first equation minus the second one. Why do we do that? It's just because we want to eliminate these two parts here, 3x and 3x. Okay, and what will happen? So the first equation, you always have to talk about left and right hand side. So this, what this actually means is subtract the left hand side of 1 minus the left hand side of 2, and then equals to left hand side of 2 minus left hand side of 1 minus right hand side. Sorry, right hand side of the first equation is 2, and minus the right hand side of the second equation. So this is what we get: 3 times x plus 4y. This is just what this equation 1 with the left hand side. We subtract 3x plus 6y, which is just the second equation with the left hand side, and here we have 2 subtracted 3. Okay, 2 minus 3. Now what does this give us? Actually, first of all, you see, we open the bracket, we have to minus 3 to make this minus 3x, and this will change its sign to minus actually 2. On the right hand side we have minus 1. And now let's look what happens here. We have 3x minus 3x, which will give you 0x actually. This was the reason why we actually did this. And 4y minus 6y will give you minus 2y. Okay, now we have minus 2y equals minus 1. We just have to divide this by minus 2. Okay, we get minus 1 over minus 2. The minus sign just cancels. We get 1 over 2, which is actually 0.5. Now what can we do with that? We just have a look again at our first equation: 3x plus 4y equals 2, 1x plus 2y equals to 1. But now we know actually what y is. We know the value of y. We just calculated that. We know that the value of y is equal to 0.5. Okay. Now what you can do is actually you can choose which equation you want to plug this in. Okay, because every equation is telling you the relationship of x and y, and if you plug in your y, you will get the your x that you are looking for. And now I chose the easier equation, which is the second one. Why? Because we only have 1x. Okay, 1x plus 2 times y multiplied with 0.50. Okay, 0.5. And what we get here is 2 multiplied with 0.5 will give you 1. Here we have 1x. I could have left this out, but I just took this with me. And this is x plus 1 equals 1. If you subtract minus 1, not subtract minus 1, but subtract 1 at the left and right hand side, you get x is equal to 0. So we found out x and y. So our pair of solutions our pair that solves the system of linear equations is x equals 0 and y equals 1 over 2. Now, maybe you already recognize that I have put here method 1. Now, if this is method 1, what is method 2? Okay, method 2 is a very symbolic way of solving linear equations. You use symbols instead of the full equation, so it gets very, very easy. And what we do first is I'm just changing the numbers of the equations. Actually, I'm just rearranging their order. So I have the second equation in front is 1x plus 2y equals 1 and 3x plus 4y equals 2. Now, this is the easy coefficient representation. I know many of you look at this and say, what the hell? Okay, I won't say WTF here, but you know, what the hell? But what happened here, it's actually pretty simple. If you look at this and this, so this is here, this, the 3 is here in the bottom. So actually what I did is just I left out the the variables and the equal sign, and instead of the equal sign I brought in here a bar, okay, a vertical bar. Now I just put in here the coefficients. This is actually this 2, so 1, 2, 3, 4, 1, 2, okay. Now what do I do next? The steps are pretty easy. What I do is I look at this as my first row, okay. I put this 1 because you will see why. Because we will try to take this number, so this is also called the pivot, okay. We will try to take the pivot and multiply it by something and then subtract so that we get here is 0, okay. Actually, if you look at this, 3 times 1 will give you this 3. So what do we do? What I actually do is the first row isn't changed because I don't do anything to it, but the second row will become 3 minus 3 times this coefficient, the 4 here, minus 3 times this coefficient, and this is just a 2 from here, minus 3 times the 1. So what I actually did, I took all these coefficients times 3 and then subtracted these in mentally saved coefficients from the row below, okay. I take this and subtract 3 times all these coefficients in the second row, and what I get is actually 0 minus 2 minus 1 here in the second row. In the first row didn't change anything, okay. But now look at this. What did happen? If I just bring back the old representation, I got 1 times x plus 2y equals 1. This was the first representation, and the second is just 0, because 0 multiplied with x minus 2y equals minus 1. So 0 times x, this will not be important, so this is just eliminated. What we get is actually we get minus 2 equals minus 2y equals minus 1. Okay, I wrote this down here. And if I just divide with minus 2, I will get minus 1 over minus 2. And this will give you 1/2. And the above equation is just x, 1 times x plus 2y equals 1. Or x plus 2 times 1 over 2, because this is the y. I just plugged in the y value, equals 1. So what do we get? We get x equals 0. So we got the same result. Okay. You could have even gone further here. You could have just divided this row. So this is allowed. You can divide rows by some number which is actually not equal to 0, because that is not allowed in mathematics anyway. So what you do is actually you divide this coefficient, this line with -2, you would get 1 minus 1 over -2, which would give you 1 over 2. So you would actually automatically see what your value for y is. It would be 1 over 2. Now, okay, just have a look at the second example. Okay, 3x plus 7y equals 1, 5x plus 2y equals 2. So let's do it with the simple way, or the old way. We just look at the leading coefficients. You see we have a 3 here, we have a 3 here, and we have a 5 here. So what do we have to do? We have to multiply this equation with 5 to have 15 here, or 3 times 5. And then the other equation we multiply with 3. So just take this coefficient, multiply out here, and this coefficient with the second equation. So what do we get? What we get actually is, I've written this down, so what we get is 15 times x plus 7 times 5, which will give you 35y, equals to 1 times 5, which will give you 5. And in the second equation we get 15x plus 2 times 3, which will give you 6y, equals 2 times 3, which will give you 6. Okay. Now we have this pair of equations. What do we do next? We just subtract them. So the easiest way is just to subtract 1 minus 2. Okay. Subtraction. Okay, I've made this in German with K, so you have to do this with the C. Okay, subtraction. Okay, 15x plus 35y minus 15x plus 6y equals 5 minus 6. Okay, what did we do? This is the first equation, the left-hand side, minus the left-hand side of the second equation, and then the difference of the right-hand side. Okay. We can do this step because we have something like an equilibrium. Okay, because both parts of your equation, so the left-hand side and the right-hand side, are always in equilibrium because of the equal sign. You can just add them. This is equal, like 2 equals 2 and 5 equals 5. You can just add them or subtract them. This will be always true. So what do we get here? We get 15x minus 15x, which will give you 0x. So we eliminated our x. We get 35y minus 6y, which will just give you actually 29y. On the right hand side we get minus 1. Okay, what do we do next? We divide with 29. We get minus 1 over 29. Now what do we do next? We'll look at which equation is simpler. And actually you can take any equation that you like, if first or second. So I just took the first one. Actually it's a bit harder than the second because we only would have to multiply with 2. But just do it because it does make a difference. 3x plus 7 multiplied with the value of y, because this is the first equation, minus 1 over 29 equals 1. We bring this part to the right hand side. So what we actually look at this is the linear equation, because this is some number, we can call it b, this is a, and this is c. Okay, so what we do now is we put this to the right hand side, but this will change this minus to a plus. Okay, so we have 3x equals plus 1 plus 7 multiplied with 1 over 29. What we do next is we have here a sum of fractions. What we have to do is to find the same denominator. Okay, the same denominator, we have 1, which you can rewrite always as a over a, and this is 29 over 29, because this is the easiest way to do it. 29 over 29 plus 7 over 29, because 7 multiplied with 1 over 29. Okay, so you can just draw this in here. And now we can add them, and you get 36 over 29. and now we have to divide with 3, and we get actually only 12 over 29. So we solved also this method. I'm going back here, and you saw our pair was 12 over 29, and the y value was minus 1 over 29. Now let's look what would we do with the second method, and this is also very valid method, very easy to do. So what we do actually is we look at the equation. We have here 3x plus 7y equals 1, 5x plus 2y equals 2. What we do first is we put this in this representation. This is also called the matrix, the coefficient matrix, and this is the appended matrix. So we added this to our matrix, and we have the values 3, 7, 5, 2, and 1, 2 on this side. Okay. Now what do we do next? Remember, we first had to, this is the pivot, we have to divide this row by 3. We will do so. So we are doing this only in the first equation. We get 1 equals 7 over 3 and 1 over 3, and the second equation didn't change. Okay, so this is what we got. Now what we do next is we remember what we had to do next is we have to make this spot 0, and we do this by taking a multiple of this row and just subtracting this from here. Okay, we multiply this row times 5 and subtract it here below. So we get 5 minus 5 times 1, 2 minus 5 times this value, 2 minus 5 times this value. Okay, these coefficients 5, 2, 2 were just taken from here. So we get to this equation 1, 7 over 3, 1 over 3. This is just the first row. We didn't change anything. 0, 2. So here I just did this for fraction, so we had only 2, but I just needed the same denominator, so I multiplied with 3 and divided with 3. So we have 6 minus 5 times 7, okay, over 3. This is what we got here. And on the right hand side I did it again because here I have a denominator of 3. So we have 2 times 3 over 3 minus 5 times 1 over 3. I forgot to put here a dot. I'm just doing this dot here maybe, so hope you can read it. So this is a dot here and not 5 vols and 1/3. So we have this, and this simplifies to the following, or it also could mean it becomes very, very hot. It's 1, the first row, I won't mention the first row because I don't change it anyway. So we have 6 minus 35. This will give us the minus 29 that we met before over 3, and on the right hand side we get 1 over 3. So what we do next is I have to multiply it with the inverse of that, okay, or the reciprocal of that. First row didn't change, so if I multiply this row out, 0 times 3 over minus 29 will just give you 0. Minus 29 over 3 multiplied with 3 over minus 29 will give you a 1, which is here, and 1 over 3 multiplied with 1 over with 3 over minus 29 will give you minus 1 over 29, or minus 1 over 29. So we just imagine this to be the linear equation again. This was the coefficient of the x in the first equation. This was the coefficient of the y in the first equation. This is what the first equation equals, 1 over 3. 0 times x in the second equation, 1 times y in the second equation, minus 29, 1 over 29 in the second equation. And now you see this is pretty good because this is eliminating this, and y is equal to minus 1 over 29. I told you so that a y here is the 1 here is very cool because you can just read it out what your y is. Now just plug this value into one of the equations, which is just easier for you, and I just plugged this into the first equation because these are equivalent to them. Okay, what we just here did was to divide with 3, so I just plugged this in and I got x plus 7 over 3 multiplied with minus 1 over 29 equals to 1 over 3. So x is equal to 1/3, and we have to put this part 7 over 3 multiplied with minus 1 over 29 to the right hand side, changing its sign to a plus. We get 7 over 3 multiplied with 1 over 29 equals, so we have to first multiply this times 29 and this times 29, and we get 29 over 3 times 29. Why do I do this? Because we have fractions, and the second fraction has 3 times 29 as its denominator, so we only have a 3 here. We have to multiply with 29 here and here, so we get to this 29 plus 7, which will give you 36 over 3 times 29, and the 3 is just canceling out, and you get 12 over 29, which is actually the same solution as we had before. Now we had both examples. So the first method was just multiplying the first equation here with this 5, and the second equation was this 3, and then just subtract them and you would easily get y. This is actually the most easiest way to solve this kind of equations if you only have 2 variables. But the second way is much better for equations with 3, 4, or 5, or even more variables. The second method is just better. So the second method was just to put only the coefficients in such a form, in the coefficient representation, then bring here, start with the pivot, okay, divide with 3, so you get 1, 7 over 3, and 1 over 3. And then what you had to do is just to eliminate. So our reason is to bring here zeros below of the pivot, then you go further. But here we didn't have a reason to go further, but you will see now, because we have a harder example. Actually, I chose the numbers so that it's still easy to solve. So just numerically, it's always the same thing that you do, but numerically it can be sometimes a hard job to do it. Okay, so let's look at this. This is 1 times x plus 3 times y plus 1 times z equals 0. And I already wrote down the coefficients. You can read them out, and I just rewrote them here in matrix version. Or so this is the coefficients here on the left hand side, and this is the solution vector. It's also called vector. Do not mind what this actually means. It's just because it has many, it's not only one value, it's 3 values, so this is called vector. And so this is the representation we start off. Now what we do next is, just look here, I did it all actually here. I just take the first row, multiply it by 2, and then subtract it from the second row, okay? So we get 2 minus 2 times 1, 2 minus 2 times 3, because of this 3, 1 minus 2 times 1, 0 minus 2 times 0, okay? There, I actually could have left this out, but I did it for a reason so that you can see that we multiplied all these coefficients above with 2. In the second case, we do the same. We have 3 minus 3 times this row, okay? No, not this row, but this coefficient. And here we have this coefficient, here the 1, and here the 0 again. So now just look what happens. And the reason, so we started off only with a pivot. We have a pivot of 1 here. We took this to eliminate here below, so we have only zeros below. Okay, Now we need to find a second pivot, and we will choose this. But before doing that, I just multiplied with -1 the row. It didn't actually change, only the signs that change, and here because of the 0 nothing big changed. Now what we have to do is look at this. We have to multiply this row 2 times and then add this to this. Okay, so we get 0 here. This is the idea. You could just divide -8 with 4 and you would get the multiplier. You could do this here actually. 2 divided with 1 will give you the 2 multiplier, and 3 divided with 1 will give you the 3 multiplier. So we have to multiply this row times 2 and then just add it, okay? Because if I would subtract it, I would get -16, but I want to add this so we get 0. Okay, this is also important. Adding and subtracting depends on so that you get a 0 here. So I do this and I will get 8 minus 2 times 4 minus 1 plus 2 times 1 plus 1, and not plus, 1 times 2 times 0. So look what we get now. What we got now, this is looking good, but maybe we should have a look in the equation form of it. So what this actually means, we have in the first equation, we have 1x plus 3y plus 1z, and this should be equal to 0. In the second equation, we have 0x here plus 4y plus 1z equals 0. And here we have 0x plus 0y plus 1z equals to 1. Okay? Now what do we do next? Look at this equation. So this is eliminated, this is eliminated, and this is eliminated. Actually, what we have written down here is z equals to 1. Okay? But if z equals to 1, I can just replace it in here. Okay? So I get a much easier equation. I only have 2 equations now. I have 1x plus 3y plus 1 equals to 0, and now I have x plus 4y plus 1 equals to 0. So now I can solve this equation. I just put, this is 1, I put it to the right hand side and divide with 4. So I get y is equal to minus 1 over 4. Here. Then I just plug this in the above equation, and I get this 1 times x plus 3 times minus 1 over 4 plus 1 equals to 0, and x is equal, now here comes the handy trick, I put this to the right hand side, changing its sign, and this to the right hand side, changing this minus to a plus. So I have 3 over 4 minus 1, which will only give you minus 1 over 4. So our pair of solutions is x is equal to minus 1 over 4, y is equal to minus 1 over 4, and z is equal to 1. Okay? So I hope you like this video, and I hope it helped you to understand the concept of solving these equations. It's not very hard. It's just a long way to solve bigger equations, but the method stays the same. Just rewrite it in matrix form and then start off eliminating row by row. Okay, column by column. So you start off with a pivot, subtract a multiple of this row from the rows below, so you have something easier. And here we have 4 plus 4 1 0. And you do the same. Take this as a pivot and then subtract or add the multiple of this equation. So you eliminate this. It's very important to have. This is also called the echelon form because it's looking like an echelon. Okay. This is the echelon form, and you just put it. There is actually a way to write these equations so that you can actually see your solutions directly, but I won't bother you with doing so. This is just enough to do it, because if you would just bring it back to the equation form. It's very easy to solve. Okay? Like always, I thank you for watching, and I hope you now understood how to solve linear equations and systems of linear equations. And if you still have questions, feel free and comment in on my videos. Ask what you didn't understand, or if you like me to do a special video on some topic, just do this and I will try to do it as fast as I can. Okay, so see you guys.